Welcome, geometry students, to the mid-chapter review, page 189, numbers 1 through 20. Let's go ahead and get started with the work today. And here we go. Directions for 1 through 6 say choose the best word to complete the statement. Either no, or 1, or 2, or 3. So here we go, okay? An obtuse triangle has how many obtuse angles? Well, the answer is always 1. It would be impossible, students, for a triangle to have an obtuse angle like this, and then another obtuse angle here like this. You would end up with a four-sided figure, okay? A triangle can only have one obtuse angle, okay? Alright, moving on to number 2. A right triangle has how many legs? Well, a right triangle always has one hypotenuse right here, and it has 2 legs right here and right here. So the answer is 2. Okay? Alright, number 3. An acute triangle has how many acute angles? Well, an acute triangle will always have three acute angles. Always 3. Okay? So each angle will be less than 90. Okay, so the answer is 3. Number 4. An isosceles triangle has at least how many congruent sides? Now remember, an isosceles triangle can have 3 congruent sides. That's fine. But it must have at least 2. So it can also have 2 congruent sides, okay? So an isosceles triangle must have at least 2 congruent sides, okay? An equiangular triangle has how many congruent angles? Well, 3. Remember, an equiangular triangle has angles of 60, 60, and 60. Okay, a scalene triangle has how many congruent sides? Well, the answer is 0. The definition of a scalene triangle is a triangle with no congruent sides. Okay, so there we go. Let's move on to numbers 7 through 10. Okay, using this diagram right here. All right. Okay, here we go. What do the directions say? The measure of angle 1 is 35 degrees. So we do know that. The measure of angle 1, which is right here. Let's make it a little bigger for you guys to see here. The measure of angle 1 here and here is 35 degrees. Okay? Alright, here we go. What is the measure of angle 2? Now, I think they also tell us, let's see, the dashed line is parallel to the base. So we do know that this line here is parallel to this line here. We do know that, okay? Now they want to know what the measure of angle 2 is. So see this line right here, students? This line right here. Watch this. I'm going to extend that line down and extend that line down, and I'm going to put angle 2 is right here. I'm going to slide this out of the way. Look what I have. I have 2 parallel lines cut by a transversal, and this angle here and this angle here are called alternate interior angles. And we know when 2 parallel lines are cut by a transversal, alternate interior angles are congruent. So the measure of angle 2 is 35 degrees, okay? 35 degrees. Alright, let's continue on here. What is the measure of angle 3? Well, let's think this through here, okay? If I know the angle of 1 here is 35, let me change colors here quickly. I know this is 35, and I know this angle here is 35. Now think about this. I have 2 slashes here and 2 slashes here, which means angle 3 and 5 are congruent. So this angle here is also 35. Now I have a triangle right here. And remember, triangles always add up to 180 degrees. So I have 35 plus 35 is 70. So angle 4 has to be 110. Now, here's a straight line. See the straight line right here? And I've got an angle coming off here, or a line coming off here, and a line coming off here. So I have an angle here, 35 degrees. I have an angle here, 110, and then an angle here. Well, all 3 of those angles have to add up to 180 because I have a straight line, and we know a straight line is always 180 degrees. So if I have lines coming off of it like this, I just took 180 and split it up into 3 angles, okay? So with that in mind, I have 35 here plus 110 is 145. So that angle 3 must be 35 because 35 plus 45 is 180. So I have 35, 110, and 35. So what is the measure of angle 3? 35 degrees. What is the measure of angle 4? Well, we already found that, and the measure of angle 4 is right here, 110 degrees. As the sand continues to fall, 2 and 5 will remain congruent. What measure must 2 and 4, what measure must 2 have when 4 is a right angle? Okay, so let's figure this out. Okay, first of all, we have a triangle right here, okay? Let's go ahead and copy this triangle very quickly here. Okay, here's the triangle right here. Okay, there's the triangle. Now I'm going to pull this out of the way. Okay, now they're saying when this angle right here, angle 4 right here, hits 90 degrees, what must angle 2 be? Well, remember, angle 2 is going to stay congruent to angle 5. Okay, so if this is 90, then I need these two angles here to add up to 90 also to give me 180. So if these two angles are congruent and they have to add up to 90, then we have 45 and 45. So angle 2 must be 45 degrees. Okay? All right. Moving on. Okay, the directions say decide whether the statement is true or false or cannot be determined. Okay, using this diagram over here. Alright, here we go. Triangle ACB, so this triangle here, is congruent to triangle FDE. Now remember, if we're going to prove that, or if we're going to be confident they're congruent, we have to use either side, angle, side, angle, side, angle, or angle, angle, side. So, let's see what we have here, okay? We have, first of all, this side here is already marked congruent to this side here. And we know we have an angle here that's 90 and an angle here that's 90. Okay, let's see what else we can come up with here, okay? Well, I see this right here. Watch this, students. I see that I have a parallel line right here. And a parallel line. See that, okay? They both have red arrows, so they're parallel. And they're cut by a transversal, okay? See that, okay? Now look, this angle here and this angle here are alternate interior angles. Let me show you. Okay, here's your parallel lines. Okay, right here, parallel line cut by a transversal. So this angle here has to be, let me change colors here. This angle here has to be congruent to this angle here because they're alternate interior angles. So I'm looking pretty good then, because I now can state the following. I know that this side here is congruent to this side here. I know this angle here is congruent to this angle here. And now I know this angle here is congruent to this angle here. Look what I have. Angle, side, angle is congruent to angle, side, angle. So, yes, I can definitely state those two triangles are true, and my reason would be angle, side, angle, okay? Now, can I state that BC is parallel to ED? Well, listen, guys, we've learned 4 ways to prove that lines are, actually 6 ways to prove that lines are parallel. Remember? That's really good. Let's try that again. Alternate, I'm just going to put AI. Alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. And consecutive interior angles are supplementary. Okay, so we want to see if we can prove that this line here is parallel to this line here. Well, look, these two lines right here, B, C, and DE, are cut by a transversal. And look what I have. I have 90 degrees here, and I have 90 degrees here. Now students, if you take this whole object here and you turn it, if we can do that, not sure if we can, yes, and we turn it, we have two parallel lines cut by a transversal. What do we call these two angles here? You guys should know this by now. What do we call this angle here and this angle here? Alternate exterior angles. And look, they're congruent, 90 and 90. So whenever two parallel lines are cut by a transversal so that the alternate exterior angles are congruent, then yes, those two lines are definitely parallel, and we can state that, okay? So the answer would be yes, we know that for sure, okay? Now, do we know for sure that AD right here is parallel to CF, and CF runs from here to here? Well, yes, definitely we know that. How do we know that? Watch. Well, look, guys, we already know this segment here is congruent to this segment here. So let's make a number up. Let's just make a number up. We're going to pretend AC has a length of 6. Now, if AC has a length of 6, then DF also has a length of what? 6. Now, pick any number for CD that you want. Doesn't matter. Any number you want. You can say 50 if you want. It doesn't matter, okay? If CD has a length of 50, then the length of AD is 56, and the length of FC is 56. So yes, AD is congruent to CF, definitely. Okay, number 14. ABC or ACB is isosceles, okay? ACB, triangle ACB is isosceles. Now, I mean, it could be. All that we'd have to know is that this side here is congruent to this side here. So it could be, but we do not know for sure. We have no way to know if this side here is congruent to this side here. Okay? So no, we do not know for sure. Cannot be determined. Alright? Okay, moving on to numbers 15. Number 15 are the two hardest ones, 15 and 16, okay? We're going to do some proofs here. So here we go. Okay, we are given that AB right here is parallel to CD. So I'm going to put a little arrow here and a little arrow here. Okay? Here we go. Now, we're also told that AC, put two arrows on this line, is parallel to BD. So put two arrows on this line. There we go. Okay? So this line here is parallel to this line here. Okay? And this line here is parallel to this line here. Alright? Now, from that information, we're going to prove that triangle BAD is congruent to triangle CDA. Alright, so really, to be honest with you, all that we need from this drawing is just this part right here. So I'm going to go ahead and take my pen here. Let's see if we can't kind of cut this out a little bit. And let's see if that helps, okay? Alright, there we go. This might not be a good idea, so we'll see. If it's not, then we'll just start over, okay? Alright, this is A, this is B, this is D, and this is C, okay? Now, let's see. This is really one line right here, so I should have made a better note of that's one line, okay? If you look right here, that's one line, okay? So this is one line right here. One line. Okay, very good. Now, the only way we can prove these two triangles are, we got brainstorm here, okay, students? The only way to prove that these two lines are congruent is to use either the following, okay? Side, 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 angle, or angle, angle, side. Now, we know both triangles have a congruent side right here, okay? We can see that, okay? We know that. But we also know this, if you think about it. We have a parallel line, watch this, cut by a transversal. So we know alternate interior angles are congruent. So we know this angle here is congruent to this angle here. We know we can state that, okay? So we're going to call that angle 1 and angle 2. Now, we have parallel lines here and here, correct? And here's my transversal. Now look at this. I have alternate interior angles, so I know I can state this angle here is congruent to this angle here. I know I can state that, okay? So we're going to call those two angles 3 and 4. So students, it looks pretty obvious to me. I have angle, side, angle congruent to angle, side, angle. So I definitely can prove these two triangles are congruent, and I'm going to use this method right here. Okay, so I think it's best if I get a little better drawing over here. So here we go. We have one triangle here. Oh, that's not good. That's amazing. There's one triangle there. And let's take the other triangle. And let's turn it around. And there's the other triangle, okay? Now, remember, we can state that this angle here, 1, is congruent to this angle here, 2. We're just brainstorming, okay, guys? We're just brainstorming. And we can state that by what? They are what type of angles? Alternate interior angles, okay? And we can also state that angle 3 is congruent to angle 4 because they're what? Alternate interior angles. We can also state that AD is congruent to what? AD, because it's the same line. So we should be good, okay? That's angle, side, angle. Let's see what happens, okay? Here we go. So we have this here with 2 slashes. Angle 3, angle 4, and then put a slash here and a slash here. So we have angle, side, angle, congruent to angle, side, angle. So this should work pretty good. So here we go. Let's put it, we'll write real small over here. So number 1 is my given. Okay. Next, I'm going to go ahead and state quickly that AD is congruent to AD. Okay. Of course, that's going to be the reflexive property. Reflexive is good enough. That's fine. Next, I'm going to state that angles, watch carefully, angles 1 and 2 and angles 3 and 4 are what? Alternate interior angles. How can I state that? Definition of alternate interior angles. Okay? Now, once I've stated that they're alternate interior angles, I can now state that they're congruent. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And that would be because of alternate interior angles are what? Congruent when dealing with parallel lines. And look what you stated, guys. Watch carefully. You stated AD is congruent to AD. You stated 1 is congruent to 2. You stated 3 is congruent to 4. So you're definitely ready to state triangle BAD is congruent to triangle CDA. Okay? And the reason would be angle, side, angle. Okay? One more proof, and then it gets a little easier after that, okay? Okay, here we go. Angle F is congruent to angle BDE, and they've already marked that for us here. Angle F, angle BDE, and BE bisects angle FBD, so we know this angle is congruent to this angle. So this is pretty easy. It looks like we have two triangles sharing a common side. So really we have angle, side right off the bat, okay? This is pretty easy to do. So let's go ahead and get a better picture. Let's split the two triangles up. And so we have this triangle here and this triangle here. Okay, there we go. And so we have F, B, E, and we have B, E, D. Now we know we can definitely state that BE is congruent to BE, and we know for sure we can state this angle here is congruent to this angle here. Let's call them angles 1 and 2. And we know we definitely can state this angle here is congruent to this angle here, because that's given to us right here. Okay, so we'll call those angles 3 and 4. So if it's okay with you guys, I'm going to call angle F angle 3, and I'm going to call this angle here angle 4, okay? And so here we go. Let's go ahead and get started. This should be pretty easy to do, okay? Number 1, we have our given. And don't forget, in your given, you've already stated that angle 3 is congruent to angle 4, okay? Now, next, very quickly, I'm going to state that BE is congruent to BE. That's pretty easy. It's the same side right here. Okay, so we call that the reflexive property. Okay, now look at this. Right here in your given, look at your given. BE bisects this big angle. Okay, this big angle right here is cut in half by this angle here. So I can state that angle 1 is congruent to angle 2, and the reason would be definition of an angle bisector. Okay, definition of an angle bisector. So look what you've stated in your proof, students. You've stated 3 is congruent to 4, so you stated this. You stated BE is congruent to BE, so you stated this. And you stated angle 1 is congruent to angle 2, you stated this. So I have angle side of one triangle congruent to angle side of another triangle. So I'm definitely ready to state that triangle FBE is congruent to triangle DBE. And the reason, of course, is angle side. Okay? Alright, let's go ahead and continue on. Okay, numbers 17 through 20 are pretty quick problems, so we're almost done here. We're going to state the postulate or theorem that can be used to prove that the blue and yellow triangles are congruent. Okay, so I'm going to go ahead and write down our options over here, and I'll cut and paste those. We can either use side, 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 angle, side, angle, angle, side, or angle, side, angle. Okay, so there we go. And let's see how it goes, okay? Alright, now, in this triangle here, the yellow triangle, I have an angle congruent to an angle. I'm going to split the two triangles up here. I have this. There's the bottom triangle, the blue triangle. Then I have the top triangle that looks like this. Okay. And notice I have this angle here congruent to this angle here. And I have this angle here congruent to this angle here. Well, students, look, they share a common side. So I can state this side here is congruent to this side here. So I have angle, side, I have angle, side, angle, congruent to angle, side, angle. So there's the reason. Angle, side, angle. Okay? I'm moving on to number 18. Now, in this problem here, I don't think I need to split the triangles up, because I can just look right here and see I have two lines intersecting. So this angle here and this angle here are called vertical angles. They're congruent. So I can put 2 marks here and 2 marks here. So look what I have. I have angle, angle, side, congruent to angle, angle, side. So there we go. Angle, angle, side. Okay? Number 19. Okay, here we go. Same thing almost. We have 2 lines here that are intersecting. So we know this angle here and this angle here are vertical angles. So we can definitely state that this angle here and this angle here are congruent. So we have side, angle, side of one triangle is congruent to a side angle side of another triangle, so we can use side angle side. Okay. And then number 20. Well, this one's already done for us, guys. Look, we have one mark here, one mark here. So the side is congruent to this side. Then we have one mark here and one mark here. So this side here is congruent to the side here. Then we have two marks here and two marks here. So this side here is congruent to this side here. So we have side, side, side. Okay? And that's it, students. I hope this mid-chapter review has been a good review for you. If you have any questions, don't hesitate to call or email.